Breaking news. What are polymers? Huh? I don't know. Well, polymers are defined as a series of molecular compounds characterized by repetition of multiple atoms and or molecules that when combined from macromolecules or with more specialized uses. In modern society, there are two different types of polymers. The synthetic ones, which are man-made, and the natural ones. To show how different polymers are used in society, this video essay will compare and contrast the two polymers, mammalian tooth animal and reinforced concrete, in a multitude of different topics.
Reinforced concrete and enamel are actually composite materials, meaning they are a combination of two or more compounds.
And now of the structure.
I'm here to check if this is reinforced concrete. Let's check. This is reinforced concrete.
Är inte det trä?
Oh, this... Yeah, this is concrete.
Nej.
No, sorry, I meant this. Both enamel and reinforced concrete have a hard surface, however function differently. Enamel inhibits a strong and hard surface as it primarily consists of inorganic ions, like calcium and phosphate, that form hydroxyapatite crystals. Enamel also contains trace minerals such as calcium, strontium, magnesium, lead, and fluoride that results in a more soluble material than pure hydroxyapatite crystals. This negatively affects the integrity of the outer enamel. Reinforced concrete becomes hard and sturdy because of the chemical reactions between the aggregate, which is the filler-like sand, the cement paste, and the water, causing a hydration reaction to occur. Different types of aggregates and different amounts of water are added to create different concrete. The tensile nature of concrete is a huge hazard. Therefore, it is commonly reinforced with internal patterns of street rebar or other shock-absorbing materials, such as fiber reinforced plastic or other polymeric compounds that are intertwined with the concrete to increase the structural integrity. By reinforcing the concrete, it receives less stress while allowing the steel to absorb a greater shock or force. Another difference is that they cohere differently. Enamel sticks together through the mineralization of enamel proteins, while cement is held together by a hydration reaction that binds the particles. However, the reinforced concrete is also susceptible to acid corrosion. This is due to the alkaline composition of the material, thereby causing a neutralization reaction. There are a couple of similarities between the two polymers. For example, both use rods in order to create better structural integrity. In enamel, these tubes are called enamel rods and are surrounded by outer enamel, while in reinforced concrete, steel rebar or other reinforcements are used. Another similarity in the composition of the two polymers is the use of calcium, which in enamel is found in the calcium ions and in concrete found in the clinker. In enamel production, interrod enamel surrounds the enamel rods, while in reinforced concrete, concrete surrounds and protects the supportive rebar. However, in teeth, the interrod enamel only makes up a tiny portion of the enamel, while the stacked enamel rods make up the most of the enamel, are highly susceptible to acid erosion or corrosion.
Now after the production. There are a lot of similarities between the production of the two polymers. One is organic while the other is synthetic. Reinforced concrete is made by mixing coarse aggregates, as you can see here behind me. Particles greater than 4.8 millimeters usually range between 9.5 and 38.1 millimeters in diameter in normal day use. But with fine aggregates, they are usually sand or crushed stone that are less than 9.55 millimeters in diameter. Now, they are mixed with water and air, and then the mixture goes through hybridization. So, step by step, first you of course mine the resources, then the limestone and clay is crushed and then mixed so that the mixture is roughly 70% limestone and 30% clay. Now, different additives are prepared. These are high purity limestone, sand and iron ore. Then you dry the products using hot gases, and after that clinkerization begins. A dark grey nodular material made by heating ground limestone and clay at a temperature of about 1400 degrees Celsius to 1500 degrees Celsius. The nodules are ground up to a fine powder to produce cement.
Enamel production, also called amylogenesis, is created by cells called amyloblasts, which form roughly 4 micrometers per day starting at around the 3rd or 4th month of pregnancy. There are 2 stages of the production of tooth enamel. The first stage, called the secretory stage, which involves proteins and an organic matrix forming a partially mineralized enamel, and then the second stage, called the maturation stage, which completes the enamel mineralization. After the maturation stage, the ameloblast proteins are destroyed, which is why teeth are non-regenerative.
Now, what are the properties? The tooth enamel is composed of both an organic and an inorganic phase. The organic phase, only 3% of the total, consists of proteins like amelogenin, ameloblastin, and tuftenin. These are acidic phosphorylated glycosylated proteins and closely related proteins involved in amelogenesis. In addition, there will be some minor concentrations of proteoglycans that are protein molecules found in the space between our cells plus the lipids, which resemble fats. The inorganic phase is composed of well-packed nanocrystals made out of calcium phosphate apatite HA, with small loads of incorporated trace elements. The organization and size of the apatite crystals mark out the extensive physical properties of the enamel. In this case, the presence of elements close to the enamel, such as food, water, or air, has the potential to impact the hardness and/or size of the enamel. The hydrogen ions have the potential to attack the tooth mineral crystals by instantly dissolving when combining with a carbonate ion or a phosphate ion. Even though they are different in bonding, they both consist of a matrix that supports the structure of compounds. Finally, an essential distinction between the enamel and the reinforced concrete is the Poisson's ratio. The Poisson effect is the phenomenon wherein a material tends to expand in the direction perpendicular to the compression. The enamel has a maximum value of about 0.54 Poissons, which is over the range that stands between 0 and 0.5. This means that once it is compressed, the possibility to bring it to its original form is impossible, while the reinforced concrete has about 0.1 Poissons. Now, how does it function?
The function and uses of the compounds differ greatly. Reinforced concrete is used in construction and in buildings, bridges, foundations, floating structures, and even roads. Enamel in teeth, on the other hand, is specialized to protect the inner and most delicate parts of the mammalian tooth. Enamel is sometimes confused with vitreous enamel, which is used to protect objects from the elements, creating a hard protective outer layer. Teeth enamel, made from hydroxyapatite, has a completely different set of uses. Hydroxyapatite is used as some baby powders in order to moisturize the skin, but more importantly in medicine as materials in bone grafts, for example in hip replacement surgery. It is also used in archaeology, where it is used to identify diets, migration patterns, and more. Lastly, hydroxyapatite is also readily used in the sterilization of drinking water. However, this increases the pH value of the mixture to form an alkaline solution. Thereby, enamel serves as reinforcement or protection for the inner tooth, while steel rebar primarily acts as a support for the outside layers of concrete. This means that they are both used as supports for other materials, although they support it in a polar opposite way.
Now, what are the associated effects on the environment?
Mammalian tooth enamel decompose slowly in nature. Both polymers are long-lasting, and thus taking a long time to decompose. Mammalian teeth enamel is produced naturally by the body and therefore does not pollute the environment. Concrete, however, contributes to 8% of the total man-made carbon emissions, most of which is caused by heating up the cement. The use of concrete in roads and in buildings decreases the amount of soil, and that is able to pick up water during floods. The dark color of concrete contributes to urban heat island effect, which is explained as when a metropolitan area is significantly warmer than its surroundings, and that most larger cities become very warm. A solution to this is, however, to use lightly colored concrete in place of asphalt. Decaying concrete contributes to dangerous air pollution and also discourage the use of carbon neutral alternatives like wood.
Thank you guys for watching and have a good day.